Hello, Claire. Well, my name is Fikadu. Today I'm gonna show you how to do the coin toss project. So I did it many times on my computer. So to save my time, I just write it down everything, and then I'll explain everything what I did, and then I'll run it to prove it is work or not. So let's begin. First, I just actually define m, so a factor, and then after I define factor and then accumulator, put one and arrange because we need 1 comma 1 plus 1. So the accumulator is I, that means we define the function, and then we assign the accumulator as 1, and then we use return, and then return accumulator, and then after that we define as same name, or whatever define it, and then n comma m, and then we put this way to define, and then number is equal to factorial, and then comma n, denomial 1 is factorial m, and denomial 2 factorial n minus m, and then denomial 1 times denomial 2 is denomial, and then return is return and number over denominator. And then we goes to the second function and define probability head. So probability head n toss, and then n slash h comma p slash h. So probability of nh head if n toss are made with coin having probability of head. So that means we assign ph. So p at probability of toss is equal to 1 minus probability of head, and then we put n toss, n time of toss minus n times of h. So the value of n toss comma n slash h times p slash h, and square root of n minus h times bracket times p slash t square 2 times n minus t, we close the bracket, and then we can define the probability of a tail, and then when you define the probability of a tail, we have n toss and then probability of head. So print out the probability of getting all combo of the head and tail. So we assign accumulator 0. So we go to accumulator 0, and then we print 13 and then slash 1, and then print number of the toss and the toss. So number of n toss, and then we print probability of head. Probability of head is probability of tail is 1 minus p8 probability of head. So we print 13 times, and then we didn't get anything, and then we put the format form on the row. So that means 0 1 2, and then format head tail probability of event, and then goes to for nh in range n toss comma minus 1 comma minus 1, and then it goes to n times of tail is n toss minus n times of head. So the accumulator is plus or minus probability of the head. We open the bracket, and then n toss comma n head comma probability of head, and then we put in the form of format, we print 0 7 and then 1 7, and then we put in the table. After that we print sum of all the probability of 0 6.5. We put this whole thing to make us a table. So lastly we define the function, and then we put n toss 5 10 20 and 50, and then probability of the head is 0.5 comma 0.52 comma 0.55, and then 0.6. so the probability of tail is n toss comma probability of head, and then we're gonna run the function, to prove it's working or not. So let's run the function. I did it many times. It's working, so there is nothing wrong with that. So I hope it's working. I think this is it. So awesome to see my work result like this. So I already tried like multiple time and I finally got it. I'm so happy. I went to tutor and asked many people how to do it. So he just showed me how to use the tail and head to calculate to find the probability, the head and everything. So this is it. So this is head and the form of this is actually the real note. So we got exactly the same things right here, same thing as format you gave us. So pretty nice. So that's it. And then the second thing I'm gonna show you is a presentation. Yeah. Yeah, second thing is I did the pro I mean the project probability of error value in a presentation form. I already sent you the document, but I just wanna explain you a little bit on my presentation. So I didn't do a lot of things. I just put four slide. So I hope it's easy. And then the first thing I do is write my name, and then second thing is just yeah, and then random. You define random because it's random. So the first definition of CT is PH is created to generate a random number to determine head and tail. And the second definition of coin toss is accumulated code to get the result. And then I just jumped. Sorry about that. And then I said the third thing is I need to set up three definitions here to allow the main program to run correctly. That means the definition of factorial, product, and then definition of probability head. And then the factorial definition is accumulated that allow for the random error when I need it. So if I use anything other than I for accumulator, then the entire program is incorrect. So the fact the product is where the number of the statistical probabilities that you need to run program. So the probability of the function is that bring the two functions together to get the desired number we need. So this is all I did. And then the fourth slide I did write is the whole functions, the error value program need to have a variable to run the program. So I made the title as error result dot text. So I appended so I could compare my previous result. So I put total flip 0 blah blah, and then I already explained put everything in a format here. So the loop need to call all of the previous written definition to run correctly. So I use the for the loop to back each one up to run of each other. So the range was determined to stay within that m was decided to get the proper error percentage. So I need to have the proper code. So there is another way to do this code in which I change it to show this. So this is all I write it for today. So this is it. So when we write the error value, so I define a random value, right, to define the head and tail, and then also the coin toss. I define coin toss both, and then again I next added I need three definitions to allow the main program to run correctly right here. And then last thing is added there the error value to need to have the variable to run the program. And then I made the title as error result or text appended, so I could compare my previous results. So I did this and then I got all the things right. Thank you. This is all I get for today. Thank you. Yeah, right here. And the last thing I did is actually the last thing I did is extra credit project. So I did a triangle that have many, like at least 6-7 triangle inside of it. That's like a pyramid. So I actually write that in the form of turtle. So I define the I define it. So I use the easiest way. So point color mask, I define all this, and then I fill color and I turtle up, and then put all these things you show us in class, and then my turtle go to, and then point blah blah, and then I define a midpoint. That's the easy way I use it. So I define the midway, return blah blah, divide all that, and I define a key point, degree, and metal. So the color maps added cyan, red, yellow, navy, and yellow. Navy is my favorite color, so I put navy, and then yellow, green, long green. So I put draw triangle point, Columbia color map, and degree metal. So I use the conditional as if degree is greater 0, the point is there, get midpoint here, and a point here, get midpoint 0 and a point 2. So I'll follow this rule, and then I use super point is 1, get midpoint 0. All these things are the easiest way I got it when I read think like a scientist. I think like a Python. So I put this, and then here, and then I define main, my turtle right here, my win turtle screen here, and then blah here. So I ran it. So so I ran it. I got exactly what I need. So here it is. Right here, triangle schooler. So, it's worse. It take me a lot of time to do this. I went to tutors. I don't even know what I asked them, so they just it's crazy. But I'm glad I learned it. They show me a little bit thing. Thank you. And then this is my extra credit presentation. And then the first one is normally the presentation. So right here I did this, and then this, and right here these two. So the probability right here, David, yeah, right here. Yeah, right here, the probability presentation, and this. Yes, pretty much that's it for today. Thank you. I already explained everything here. Was extra credit, and then the normal project contours and one video. So here it is. Thank you.